All right, so let's do the first three problems from the Unit 11 review. So let's see. First one, we got a circle. Radius is 12. We'll draw a little sketch. Circle, radius is 12. And there's a 150-degree arc in it. So let's see, 90 would be straight across here. So 150, a little less than 180. So something like this. So this arc is 150 degrees. Radius is 12 centimeters. And the question is, how long is this arc right here? Now, the 150 is not how long it is. That's how many degrees it takes up. So how long it is would be something in centimeters. So if I said how long is it all the way around the circle, that's the circumference, which is 2 pi r. But I don't want the whole circumference. I just want 150 degrees of it. So I'm going to take a fraction of the circumference. I'm going to take 150 out of 360 of the circumference. So this is the arc length, which I'll call L for this length. So L equals 150. It's the percentage of the circle's circumference. That's the way to think about it. And if you type that into a calculator, now it says exact form. So really the only parts you want to plug in to the calculator are the 150 over 360 and the 2 times 15. You want to leave the pi by itself. And so I'll do that with you here. So if we do 150 over 360 and then times 2 times 15, notice I'm leaving out the pi. Then we get 12.5. Oh, sorry, it's not 15. It's 12. Radius is 12. So let me call that back down here, switch it to 12. 10. So we get 10 for everything other than the pi. So I still have to multiply it by pi. So it's 10 times pi. So the arc length is 10 pi centimeters. Okay, so that's number one. Number two says find the area of a rectangle with length 4, diagonal 6. So let's draw a rectangle. Length is 4. Diagonal, we don't have units for this one. So 4 there, 6 here. And the question is, what's the area? So give your answer in exact form. So exact form, typically you want to avoid trig. Okay, so area is length times width. We know the 4, we don't know the width here, so let's call that x. And we can solve for x using Pythag. So 16 plus x squared is 36. X squared is going to be 20, so x is root 20, which we can simplify. That's root 4 times root 5, so this will be 2 root 5. So then the area of the rectangle is going to be length times width, 4 times 2 root 5, which is 8 root 5. So there we go. 8 root 5, area of the rectangle. Number 3 is another exact form problem. So here we've got an equilateral triangle on one side and this trapezoid on the other side. So we're going to divvy it up that way. We'll find the area of each one of these by themselves. So let's take the triangle by itself first. So I'll draw the triangle right here. So it's 8, 8, and 8, which means all the angles are going to be 60. And the area of a triangle is 1/2 base times height, so I need to draw on a height, which cuts this into 30 and 30, and the base into 4 and 4. So you could use Pythag to get the height, but you could also use the 30, 60, 90 theorem to get the height. Well, this is the 30, here's the 60, so it's 1 root 3 and 2. So the height here, we'll call it h. So 4 goes with 1, the same way that h goes with root 3. So then we get 4 root 3 is the height. So the area of the triangle is going to be 1/2 the base times the height. Oops, height's not 4, it's 4 root 3. So then that's going to be 1/2 times 8 is 4, times another 4 is 16, times root 3. So that's the area of the triangle, 16 root 3. the area of the trapezoid, we also need, and so this one I think we might as well practice using the formula for it. You could easily chop this guy into a rectangle right here, 10 times 8, and then this is 4 and this is 8, so you could get the area of the right triangle there pretty easily too. But it's just as easy to use the formula. So area of a trapezoid is 1/2, it's the average of the bases times the height of the trapezoid. So 1/2 10 plus 14 times 8. So that's going to be half of 24, which is 12, times 8, which is 96. So this part's 96. And so all we do is we add the two. So it's 16 root 3 plus 96. And those you can't combine and keep in exact form. You'd have to turn them into a decimal somehow. So we're just going to leave it like that. Okay, I hope that helps a little bit, and I'll see you guys later.